Okay, so what I've done here was I've just photocopied a page from the textbook. Okay, and you can see it here in the screen. I've made it fairly big. We've learned that substitution is a good technique to find antiderivatives, to find certain antiderivatives. It's helpful, but we need to learn other techniques as well. And there's a technique called integration by parts. And let me show you how this works. So, you know, there's a formula down here. There's a formula right here that says the integral of u dv equals uv minus the integral of v du. Okay, that's what it says. And okay, so how do we come up with that formula? Well, it all starts off with the product rule. So how many remember that the derivative of a product of two functions f of g equals f times g prime plus g times f prime? How many recall that? Okay, Renaud does, and hold on here. Let me look at the Sean and Leping and Marcus. Okay, yeah. So, well, look what we can do here. Now, we can take this equation and we can integrate both sides of this equation here. And so, what will happen is for the left-hand side, if you take the integral of a derivative of a function, and this function is f times g, that's going to give you just the function, right? The antiderivative of a derivative just gives you the function, right? They're opposite, they're inverse operations, so to speak. So you have f times g, and what they do is they put this on the right-hand side. I want to say this the right way here. Hold on. Let me rephrase it here. So they're integrating the left side with respect to dx, with respect to x, and they're integrating the right side with respect to x. Okay. On the left side, the integral of a derivative just gives you the function, just gives you the integrand, and that's what they get over here. And then on the right side, the integral here, they just put right here on the left side. They just switch sides, okay? Well, on the left side, you have the integral of a sum that equals the sum of the integrals. All right, so far are you okay? Are you comfortable up to this step here?
Yes,
Maybe
sir.
give me a thumbs up if you're good. Oh, yes, Samuel.
No, I was just affirming that I'm okay up until this point.
Oh, you're good. Okay.
Professor,
Excellent.
Professor.
Yes.
Yeah, I'm sorry. Can you make it bigger? I mean the screen.
Is it so I'm looking, oh, you know what? Class, on your screens, click twice on your screen, like in Blackboard, and it should come up bigger.
Yeah,
Let me
it
know if
works.
that works.
It works. Thank you, Professor.
Okay, great. Okay, so this means that okay, so what they do now, is they leave this integral on the left side, and then, you know, there was a plus here. There was a plus, right? There was a plus here, And so what they do is they subtract this integral and get it on the right side. And then this f times g is already on the right side of the equal sign. And so you've done what's called integration by parts. That's what this formula is. It's integration by parts. The integral of f times g prime is equal to f times g minus the integral of g times f prime. And that's fine. That's fine. But it's a hard formula to remember. It's a hard formula to remember. So what they do is they say, okay, well, let's go ahead and let u equal f of x and v equal g of x, for this formula here. Well, if u equals f of x, if u equals f of x, then du dx would just equal f prime of x. And so du would equal f prime of x dx. And so that's how they get that du equals f prime of x dx. Because if u equals f of x, if we're letting u equal f of x, du dx is f prime of x, and so du is f prime of x dx. Now similarly, since v equals g of x, they can show that dv equals g prime of x d of x. So if you like now in the formula here, in this formula, if you replace f of x with u, which they are, u equals f of x, g prime of x dx is equal to dv. Because you're letting v equals g of x. So u dv, the integral of u dv, is going to equal u times v minus the integral of v, that's what g of x was, times f prime of x d of x, but that's just du. And so you get then the integral of u dv equals uv minus the integral of v du. And that's called integration by parts. That's called integration by parts. And it's a handy formula for when you're trying to integrate the product of two very different functions where substitution would not work. All right, that's where it's handy. So the formula that you need to know is the integral of u dv equals uv minus the integral of v du. All right, and what we can do, let's look at a few examples. But are there any questions so far? Okay. Okay. Well, let's go ahead here. Here's an example. Let me give you a moment to copy this example down for section 5.6. Okay, so in this problem, if you were to try to do a substitution, okay, like you might like say, okay, let u equal 7t. But if you did that, you're not going to make this antiderivative any easier. Okay, you're not going to be able to make the antiderivative any easier with the substitution, because I mean, well, one issue is you have a sine of 7t, and then you have a t. You have a product of two like very different functions. So when you have that kind of situation, and substitution approach isn't going to work, you can try integration by parts. So the question is, you got to decide. Well, and remember, let me hold on here. One moment. One moment. One moment. So integration by parts, you have the integral of u dv. That equals u times v minus the integral of v times du. So you're starting off with u times dv. Okay, so you're starting off with that. Okay, and that's then going to equal this expression on the right-hand side, and hopefully that will be something that you can work with. So you're starting here on the left-hand side, and so you got to decide, okay, what am I going to let u equal, because I need a u, and what am I going to let dv equal, because I need a dv. All right, and that takes a little bit of practice to figure out. Okay, that takes a little practice to figure out. But one thing is you don't, when you apply this integration by parts formula here, you don't want the new formula you get, in particular this integral here that's gonna result on the right hand side. You don't want that to be more complicated than what you started with. Okay, so that usually helps you to decide what you're going to let u equal and what you're going to let dv equal. So let's go to the solution, and let me show you the solution. Okay, so what I'm going to do is I'm going to decide to let u equal t. Okay, so t is going to be u, and then dv is going to be the rest. dv is going to equal sine of 7t dt. And so see, I have here the integral of u dv. Well, now what I have to do is I have to find out what v is, because I don't know what v is. And I have to find out what du is, because I don't know what du is. Well, if u equals t, then du would have to equal dt. Again, that's because if u equals t, du tt is going to equal 1. And so du has to equal dt. So I know what du is. All that's left now is to find out what v is. Well, if I'm letting dv equal the sine of 7t dt, okay, if I'm doing that, which I am doing, that means v is going to be the antiderivative of the sine of 7t. V is going to equal negative cosine of 7t over 7. Now that's not easy for you to do in your head right now, because how many has it been a little while since they've seen calculus? How many of you has it been a little while? Okay, Renat, Gloria, and Audra, and Michelle, and so and Ziazi and V. So this is going to take a little time, a lot of practice, of course, if it's been a while, a long while, but that's okay. Okay, well, hey, I'm saying V equals negative cosine of 7t over 7. Let's check that out. If I take the derivative of negative cosine of 7t over 7, by the chain rule, that's going to equal negative 1/7 times sine of 7t, or negative sine of 7t, times the derivative of the sine of 7t, which is 7. And that will equal the sine of 7t. So therefore, dv will equal the sine of 7t dt. So it just means that if I let v equal negative cosine of 7t over 7, indeed, then from that, dv will equal the sine of 7t dt, and that's what I started with. So that just confirms that this v is correct. Okay, so essentially, for one side of the problem, you're taking the derivative, and for another side of the problem, you're doing the antiderivative. Now what we do is we apply integration by parts. So integration by parts says that the integral of u dv here, the integral of u dv is equal to uv minus the integral of v du. So, okay, well, this is my integral here. I call it integral I, right? So integral I is going to equal u times v minus the integral of v du. And that's what I wrote here. Okay, minus the integral of v du. So please let me know if you have any questions up to this step here. All right. Well, now, okay. So the integral here is the one I got to worry about, right? I got a negative times a negative. That's going to be a positive, and then the 7th I can bring out front. Well, the antiderivative of the cosine of 7t is just sine of 7t over 7.
Professor,
Yes, Sophie.
how did you get the 7 when you did the antiderivative from dv to v?
Let me see. Going up here. Hold on. Let me just. Can you show me what you can with your pen? You can show me, Sophie, where you're.
How do I do that?
I think. Well, I think you can. Do you have like at the top there? Sorry, like the pencil. Can you see that?
Yes. I'm just wondering where this came from.
Okay, hold on. This here.
The 7.
Yeah, it's because Dr. Duty's smart. That's a joke. I hope I'm smart though. But you're going to develop a feel, Sophie, for well, basically all I did was I said, what's the antiderivative? What's the antiderivative of the sine of 7t?
Mm-hmm.
Okay, now I'll just show you something here. If you really, okay, let me just show you something. I'll come back to this.
Okay.
Let me go to the whiteboard. Okay, let me go to the whiteboard here. So the sine of 7t dt. I want to get the antiderivative.
Mm-hmm.
So, okay, well, I can say let u equals 7t, then du is 7 dt, then 1/7 du is equal to dt.
Mm-hmm.
So this integral, will equal the sine of u, times 1/7 du. Okay, so you see what I did? I replaced your question's a very good one.
Mm-hmm.
Sine of 7t now is just the sine of u. And dt is 1/7 du. So I'm going to get then 1/7 times the sine of u du. That equals 1/7 times negative cosine of u du, plus a constant, of course. And so the antiderivative of sine is minus cosine. This is going to give me negative 1/7 times the cosine of u, but u was 7t. Okay, and so this is how that's how I mean, basically, if you have trouble doing it, trouble getting it, it's just a substitution you need to do to get there.
Mm-hmm.
And this is how I got that v. But eventually you're going to get so well practiced that you're not going to need to go through this process to get the antiderivative of the sine of 7t. You're going to be able to, like, right away put that in.
Oh, okay.
Okay, that's what's going to happen.
I see.
But for now, this is like to sort of get the antiderivative. If you didn't know that this was the antiderivative, you would have to go through this process here.
Okay.
Okay. Okay. Very good. So now, and that's it. This is all in the recording too. Let me see here. Let me go back to thing here. Okay. So then, that's the V. Okay. And so now, again, okay. Oh, the antiderivative of the cosine of 7t dt. That's the sine of 7t over 7. Well, that I'm able to do in my head just because I've had a lot of practice. And I mean, and if you differentiate, let me ask you this: if you differentiate the sine, what are you going to get? What's the derivative of the sine?
Negative cosine.
Positive cosine.
Differentiate. You said I thought you said anti-differentiate.
Oh no, well, what I'm trying to do is I'm trying to convince you
Uh-huh.
that this is the antiderivative. That this is the antiderivative of the cosine of 7t.
Uh-huh.
Derivative of the sine is the cosine.
Uh-huh.
And the derivative of 7t is 7. I want to be careful here. The derivative of the cosine of 7t would be, sorry, derivative of sine of 7t is the cosine of 7t. But then by the chain rule, you take the derivative of 7t. That's going to get you 7, but then you divide by the 7 so that you don't see it there. And then,
Got it. Mm-hmm.
okay,
Thank you.
And so we end up getting our antiderivative. We end up getting our antiderivative. So then the antiderivative of, or the integral of t times the sine of 7t dt is equal to negative 1/7 times t cosine 7t plus 1/49th sine of 7t plus a constant. That's the answer. You found the antiderivative. Okay, are there any questions on that? How many of you have maybe a little headache right now because you're learning a lot of calculus? Okay, Jacob, Nathan, and Renat. Yeah, it's not uncommon. You know. Think of it like this: you move from the minor leagues to the major leagues, basically. I mean, because after this class, you got high level courses, 200 level courses. So this is the natural bridge, and okay, all right. All right, let's look at another problem. Okay, the integral of the arctangent of 4t dt. All right, so a substitution is not going to work here. Okay, substitution is not going to work. And again, we're going to need integration by parts. The integral of u dv equals uv minus the integral of v du. Okay, so let me show you what we would we have to decide. Again, here's on the left-hand side the integral of u dv. So we have to decide what's u going to equal and what's dv going to equal. Okay, let me show you. We're going to let u equal the arctangent of 4t. Okay, so this is u. And we're going to let dt equal dv. So dv will equal dt, and u will equal the arctangent of 4t. So on the right-hand side, over here on the right-hand side, I need to find out what v and what du are. Okay, because I know what u is. No, wait, hold on. Yeah, I know what u is. And hold on here, one moment. One moment, class. Yeah, so I have to find out what v and du are. Well, if dv equals dt, then v equals t. Because dv dt, hold on, let me rephrase that. Hold on. If we took the derivative let me just see here. dv dt, let's say dv dt were equal to dt dt. That would be the case if v were equal to t. dv dt would equal dt dt. Well, that means dv dt equals 1. So dv does equal dt. So this is correct. And if you want to think about it, think of in front of the dv, there's a 1 in front of there, right? What's the antiderivative of 1? It's v. And then on the left-hand side, u is equal to the arctangent of 4t. If I differentiate u with respect to t, I'm going to get 1 over 1 plus 4t quantity squared times 4 by the chain rule. Okay, so du will equal 4 over 1 plus 16t squared dt. How many remember that the derivative of the arctangent, well, let me phrase it. This pen, sometimes you don't have as much control with it as the mouse. The mouse is like you have full control. Pen, you got to get, you know. How many recall that the rule that d dx of the arctangent of x is equal to 1 over 1 plus x squared? How many recall that rule from Calculus 1? Okay, Jacob remembers it. Sean remembers it. Jiazi. Yeah, so that's all we did here. Samuel too. That's all we did here. We just are doing the derivative of the arctangent of 4t. Well, the arctangent is the same. ARC tan is, this is just, it's the same notation. I mean, it's just different notation for arctangent. But we got to use the chain rule. Okay, so now we do the integration by parts. And we arrive at this expression here.
Professor?
Yeah, Marcus.
So real quickly, I don't know if someone already asked it, but why did you decide to make u arctangent of 4t instead of just 4t?
Right. It turns out that this is what's going to so sometimes integration by parts, it's sort of straightforward to see what would work. Or a little, this here, like, yeah, you wouldn't know this offhand. But this is why I'm showing it to you that this will work, so that the more examples you see, Marcus, the better feel you're going to get when you decide what you think U and EV are. It turns out it's going to work, and that's why I'm using this. There's no, like, I can't give like offhand a, like with substitution, you get a feel, right? You get a feel that it's going to work pretty soon, right? After you do the substitution, you sort of see quickly if it's going to work or not. Here, this is one of these where you have to take it, you have to just try it and see. And that's what we're doing. That's what we're doing.
Okay, thank you.
Sure. Okay, so we end up here. And this integral here, if we could integrate this, we would be set. So what approach do you think we can use to integrate this integral? What approach? What do you think, Jacob?
Could we try bringing the denominator up by making it a negative, like to the -1, and then combining the t with the 4?
Well, we could try it, but I was thinking of something else. I was thinking of gee, what technique did you just learn?
Substitution.
Substitution, that's right. What if we tried a substitution? I mean, what could we let U equal? What could we let? Oh, I'm sorry. I don't want to use U, because I had used that in the integration by parts. Let me choose a different variable. Why don't I say W? Okay, so instead of U equals, I'll say W equals. What do you think we could let W equal? That might work here.
1 + 16t squared.
Okay, Sophie, I like the sound of that. 1 + 16t squared. Okay, let's try that. Let's go to the next page. Okay, so we're going to let W equals 1 + 16t squared. So our focus now is finding this integral on the right side, right? Got it? If we can find it, we're good. If we can't find it, we're stuck. But if W equals 1 + 16t squared, then dWt dt is 32 times t, and dW then is 32t dt, and so 132 dW equals t dt. And so I can rewrite my right side of my integration by parts this way. Okay, let me give you a moment here to feel comfortable. Are there any questions up to this part here? All right, well then obviously I'm going to bring that constant out in front of the integral. What's the antiderivative of 1 over W? That's something you would have learned in Calculus 1.
Natural log.
That's right, Maria. the natural log of the absolute value of W. Have to remember the absolute value. WebAssign will mark it wrong if the absolute value isn't there. Wow. And since it's an indefinite integral, we have a constant of integration. Okay. So now, is this the answer? That are we going to put this answer in WebAssign?
No, you
No,
have to substitute back in W.
That's right. We have to substitute back in W. All right, and I do that on the next page. All right, are there any questions? May I go to the next page? Let me know. I want to make sure I'm not, you know, I like to make sure. See, if I were in a classroom, I could watch you as you're taking notes and you know, and kind of know when to move on. But here I kind of have to ask, you know. But everybody's good? Okay, Liping, you have
I'm
a
good.
question? Oh, you're good. Okay, you're giving me a
No, I
thumbs
just
up.
mean I could.
Oh, thank you, excellent. Oh, that's right, the thumbs up. I got to remember the. Okay, well, let's go. Let's go forward. So, okay, I'm going to substitute in the 1 plus 16t squared. That's what was W. But you know, this 1 plus 16t squared is always positive for any t, and so in the final answer, I can drop the absolute values, and here we are. Okay. Are there any questions on that? Okay. Now, you know, sometimes I'll just make a comment here. Like you can have problems like, for instance, you could have a problem like this, where you have the integral of x squared times e to the x dx. And that kind of problem, you might have to use integration by parts twice. you'll see this in your homework. There's like a guided exercise on that, and it's pretty good. So sometimes you might have to do integration by parts multiple times to get the answer. I just wanted to kind of make you aware of that, because they do an example in the book on that. But you know, sometimes like in the notes, I try to give you some. I try to make sure you have a variety of examples. So sometimes, yes, I'll do examples from the book, but then I sometimes do different examples, so you have a wider variety. All right, let me stop the recording.